Hello, my friends. It's time for another MRWC video. This one about 7a3. We're going to be looking at piecewise functions, especially the interesting thing about piecewise functions is they have different behaviors under different domains. And here in number 1a, we have a function that has a certain behavior under one domain and a different behavior under another. So for example, if we take x plus 3, what does that mean? Well, x plus 3, let's write that here, that's really a line. And the reason why it's a line is because you could write the function like this, couldn't you? And then it would be a line with a slope of 1 and a y-intercept of 3. So if it has a slope of 1 and a y-intercept of 3, that means the y-intercept would be here at 3 and would have a slope of 1. So it would go like this, and like this, and like this. Unfortunately, this coordinate system is not perfectly square. It's a 2-to-1 ratio. But that's what it would be. And I hope you'll forgive me if I freehand this, even though I don't have a very steady hand. For me, that was phenomenal. So that's what this line would look like under normal circumstances. But we're told something. We're told that this is only true if, see that if? If x is less than or equal to -1. Where is that? Well, they're talking about this -1 right here, which is on the x-axis. So basically what they're saying is only to the left of this dotted line is that true. So you know what that means? That means that all of this, and unfortunately I'll have to erase this the old-fashioned way, all of this is gone. Poof. Not there. Anything to the left of that dotted line is in the domain, and anything to the right of the dotted line is not in the domain, and so therefore it's not part of the function. Well, this dotted line is not really there. Whoop, and I don't expect you to write it. I just want it as an illustration to show you where the domain is. No. I have to re-erase that part. Okay. There we go. Now, this is less than or equal to, and so what that means is that we actually have a closed circle. So we have a little dot right here at -1, and that's going to be filled in, and it's going to be everything less than that. So that is that first function. Let's look at the second one. This right here is a parabola. It's an upside down parabola with y-intercept of 3. So under normal circumstances, that would have a y-intercept at 3, and it would go basically to right about there. Unfortunately, again, my hand is not the best. But there we go. So it would look something like that. But what's the problem? It's not that whole thing. We're actually told only if x is greater than 1. Where is that? Well, that's over here. I'm going to do a dotted line. Again, sorry for my unsteady hand. Only to the right of that line. Only to the right of that dotted line. So therefore, you know, I'm going to change colors because I know that it's going to not work otherwise. Only from here down is the function. This whole red stuff here is not part of the function. And all those red dotted lines, well, that's just a helper. That was just for me to make sure I don't violate the domain. Okay, and so that's our answer. So this is what number 1A actually looks like when you're done with it, more or less. Again, forgive my humanity of my unsteady hand that doesn't always draw exactly accurate. But more or less, for a human being, this is what we have. And this is a piecewise function. You can see that there's two different parts because there's two different domains. All right, this one here, it would be, this one would have been a parabola, an upside down parabola, but it got cut off. And so we only have that bottom right tail. Let's do 1b. And again, if you are doing this at home, please pause the video at this point and try to do it yourself without my help. Okay, and here's the solution. What is this? Well, this is interesting. So this first one here, it says square root of x plus 3. Well, if you draw that, if you write this as just a regular function, if you remember from last year, when you graph a squared function, if you remember the parent function looks basically like this. It's half of a sideways parabola. Well, plus 3 means that this is shifted over 3 units. 1, 2, 3. And should we clean this up a little bit? I think we should. I think that's better. Okay, so it looks something like that. That is this part right here. But, again, what's the problem? Why is it not that? It's only where x is less than or equal to negative 2. Well, that's just this itty-bitty part over here. And all this other stuff, so let me actually recolor this. Yeah, I'll just do it like this. It's only this part here, and everything else is gone. Now we do have a filled in circle, but the rest of that function, can you make sure it's locked? Oh, right. Okay. So then, I wasn't scared. I was...
Wait, you went outside to check the other one. I saw you.
I'm recording right now, okay? So let's just move on. We don't have time to waste. People are watching. They don't have time for this. They're going to skip ahead. And if they skip ahead, then I won't get that ad revenue, okay? I need people to pay attention. There is no ad revenue. That's a joke. There is no ad revenue. Not yet. Not yet. Okay, so what about this one here? This says 2. What the heck is 2? Is that a point? Many have thought it was a point, but it is in fact a line. Because, check this out, isn't that just like y equals 2? And what's y equals 2? That's a y-intercept of 2 and a slope of 0. Slope of 0 is a flat line. So this would be exactly, I won't mention your name, would be exactly a flat line across if I were able to draw a flat line, which I could with the tool, but oh well. But, again, the problem is that this is limited in the domain. It's only between negative 2 and 1. So it's literally only from here to here. And so I can erase this. And that's where it's true. And now let's think about filled in circles or open circles. At negative 2, it's an open circle. And at positive 1, it's a filled in circle. And that is that red part. Now, let's look at the next one. And this one is really like the line y equals 2x minus 1, which is a y-intercept of negative 1 and a slope of 2. So ordinarily, this would look something like this. This is a slope of 2, so it goes up like this and up like this. So I'll try. No, I can't do it. Maybe if I go, no. You'll just have to bear with me. So it looks something like that. But again, the domain has restrictions. It's actually only this part. Ay, ay, ay. Why is this so hard for me? You know what? At this point, I'll do the proper line. There we go. All right. So this then is gone. And you know what? We can actually extend this out. So this is a slope of 2. So I apologize. I actually did the line wrong. It should go more like that. Like that. And let's look at the ends. So for the ends, this is anything greater than 1. So it's an open circle here. And that's good, because if it were a closed circle, we would violate the vertical line test and it would no longer be a function. And remember that the name of this thing is called piecewise function. And if it's a function, then it cannot violate the vertical line test. So if you have overlapping pieces, then you know you have a problem. That should not happen in a piecewise function. No overlaps. If you have an overlap, something's wrong. You got to fix it. So this is what it is. Thank you very much, everyone. Hopefully that was helpful to you. Please like, share, and subscribe. Buy my merch, which legally doesn't exist. Thank you, everyone. Have a good day.